Okay, so we're going to go through how to calculate the density of liquids. So what I'm going to do with you first is just to go through water first. Now, you all know at this point that water has a density of 1. But how do we get that, right? So let's do that together. So here's my scale, right? And I'm going to first use a more scientific tool than I did in the previous video, right? Which is a graduated cylinder. So first I'm going to weigh this graduated cylinder empty. I'm going to put it on the scale, and I'm going to write down the mass of this graduated cylinder, 111.2 grams. Now, I'm going to add some water to my graduated cylinder, and you'll see the mass change. All right, now the mass is 146.0 grams. So the top number is the amount of mass of the graduated cylinder plus the water inside. And this bottom number is just the mass of the graduated cylinder. So, in order to find out the mass of just the water, that's what I'm trying to figure out right now. What's the mass of only the water? So if you think about it, to figure that out, I need to subtract the mass of the graduated cylinder from the entire mass. So I'm going to subtract and find my answer. Now you can use a calculator, or you can do this with your head, right? But you should end up with 34.8 grams. And if you did that using your head, you would turn this into a 10, make a 5 here. So 10 minus 2 is 8. 5 minus 1 is 4. 4 minus 1 is 3. So the water in here has a mass of 34.8 grams. So that's my mass. Right? Remember, mass, density equals mass over volume. Right? So I know that my mass is 34.8. Right? Now what's my volume? Now when we did cubes, when we found the volume of a cube, I could measure the length, the width, and the height, right? Length times width times height is volume. But now I've got water. Now, I can measure the volume using milliliters. Because remember, a cubic centimeter is the same as a milliliter. So if I measure the milliliters in this graduated cylinder, I know that the volume is, it's 35 milliliters. All right. So there's my volume. Got my mass already. So then if I'm using a calculator, right, I just need to divide the mass, 34.8, divided by 35 equals, look at that, a lot of numbers. I'm just going to report the first two after the decimal point. I'm running out of room here, so I'm going to make this really small. 0.99 grams per milliliter. See that? 0.99. Now if I wanted to round it up to 1. And there you have it, folks. The density of water is 1. Now, I could have done this exact same thing with 200 grams of water, with 5,000 grams of water, with a giant swimming pool worth of water. Doesn't matter how much water I use. If I use more water, it's going to have more mass, but also more volume. The density is always the same. Density is a property of the material that you're testing or looking at. Let's do one more with oil, okay? I'm going to turn my scale back on. We're going to do the baby oil that we did at the beginning of the year in those beakers. Okay, so I'm going to, once again, measure the mass of an empty graduated cylinder. So it's 112.8 grams, right? 112.8 grams. I'm going to add my baby oil. And I'm just adding this stuff, right? And this is what we used in that beaker earlier in the fall when we were looking at ice floating and sinking. So I added some baby oil, and that raised my mass to 133.2 grams. All right. Let's move that over. So now the total mass of both the oil and the cylinder is 133.2, and just the cylinder is 112.8. So I can do my math again. 133.2 minus 112.8. And you find that the mass of this oil is 20.4 grams. That's the oil, right, by itself. So, once again, density equals mass over volume. So I've got 20.4 grams, and now I need to know the milliliters. So I'm going to look at this. Let's see, there's the oil in there. I'm going to put it straight so I can read it better. And the oil volume is 27 milliliters. So I'm going to divide 20.4 divided by the volume, which is 27, divided by 27. And that equals, I don't know if you all can see that, 0.75 grams per milliliter. Okay? So by doing this, I've shown you how you can calculate the volume of a liquid. You use a tool, right? I'm using a tool to find the mass. I'm using a scale. I'm also using a tool to find the volume. Graduated cylinder. So you find the volume, find the mass, do the math, and there you have your density. So the density of oil is less than the density of water. And that's why oil and water do not mix. Right? Oil and water do not mix. They never will mix. Oil always has a lower density than water. It will float on top of water, in fact. All right?